Compression theory is primarily defined by the ideal gas laws and the first and second laws of thermodynamics. As originally conceived, the ideal gas law is based on the behavior of pure substances and takes the following form: PV is equal to RT. P is equal to absolute pressure, V is equal to specific volume, R gas constant, T absolute temperature. This equation is based on the laws of Charles Boyle's, Gay-Lussac, and Avogadro's. Note all properties should be defined in the same measuring system. Conversion factors. Dividing both sides by time, the total volume becomes volumetric flow and the mass flow per unit time becomes the mass flow rate. A pure substance is one that has a homogeneous and constant chemical composition throughout all phases. For most compressor application, a mixture of gases may be considered a pure substance as long as there is no change of phase. The significance of introducing this concept is that the state of a simple compressible pure substance is defined by two independent properties. Horsepower calculation. The brake horsepower required to drive the compressor can be determined by calculating the gas horsepower and then correcting for mechanical losses.